the door study is an example of changed blindness, and we can argue whether changed blindness is really a failure of attention rather than just thinking, what is really required of a person when somebody else asks for directions. It's not really important exactly what that person looks like. And in normal life, people don't just change identities all the time. So in some ways, you could also argue, well, maybe that older man is actually paying attention perfectly well. He's tasked with how to give directions, and he provides the directions. But change blindness is an interesting thing, though, that certainly in other contexts also is quite important. So there used to be this kind of bar game, this arcade game where you had to compare two pictures and find the 10 differences as quickly as you could. That's change blindness. If you think about a lifeguard in the summer looking at a pool full of swimming kids, and their task is to actually detect when somebody is drowning versus not drowning. Very difficult task, and it's basically trying to detect when changes happen, and if they miss them, that's a form of change blindness as well. And here's actually a very funny example from Iceland, where at some point I came across this news article, and let me pull it up for you. So the story is that this missing woman, quote unquote, finds herself after an intense search. And what happened here in Iceland was that, so a woman went missing in Iceland over the weekend. She was reportedly found safe and sound by herself. What happened is that this tourist participated in an intense police search for herself in this area where they had gone on a tour, basically. And essentially what happened was that at some point this woman went to the bathroom and had changed her outfit, and the rest of the tour group didn't recognize her. So when the description of the missing person was offered, as an Asian person in dark clothing, speaking in as well, the woman didn't actually realize that this was her. She was being described and thought they were looking for somebody else. They came out with a helicopter crew. Hours later, around 3 a.m. on Sunday, the search party finally realized that the woman they were actually looking for was amongst them and involved in the search, and the search was called off. So that's kind of a funny example of change blindness, where clearly people had failed to realize some sort of change, and because of that they actually ended up in this massive search for this person that was actually really not so missing. So change blindness, what affects this? How hard it is to detect a change? Well, first of all, to detect a change, it's required that you have paid prior attention to the object, right? If you haven't actually looked at an object or a person and not attended to them, then of course you're not going to detect the change either. So you have to have a prior period where you actually paid attention to it. And then what's interesting is that if you look at when people are able to detect changes successfully, people are better at detecting changes in, for example, a type of object. So for example, you can replace a knife with a fork, and people are pretty good at detecting that change, rather than with what's called a token change. And a token would just be one instance of a knife. So for example, you replace one knife, but you replace it by another knife, and that's harder to detect. So changes in type, just replace with a completely different object, that's easier to detect. Replace with a different object but from the same object category, that is actually much harder to detect. And then in general, people also have been found to be much more likely to notice changes when the object that's being replaced is something they've actually had some sort of active goal with. So if you're about to eat dinner and all of a sudden your fork has been replaced, you're highly likely to notice that. If you're just sitting at the table and drinking a cup of coffee and a fork is replaced, then you might actually not notice that. So, as I said, you can argue whether change blindness is really a failure of the attentive system, but it's interesting nonetheless. And there certainly are some other ways in which the attentional system is limited. And if you want, change blindness is an example of how attention can only be sort of allocated to one particular part in space, and if there happens to be a change in another part of space, you may not detect it. Attention also can fail in terms of the time that passes, and I'll give you some examples of that. The attentional blink and repetition blindness are two examples that actually kind of demonstrate a similar phenomenon. So what happens in the attentional blink is the following. And this also gives you a first idea of what kind of paradigms people use, what kind of tasks they use to study the attentional system. So let me work you through this. Imagine that you're sitting in front of a computer screen and you get a whole bunch of letters thrown at you in quick succession. So first you see, say, the letter F, then you see the letter L, then the letter P, then the letter O, then the letter J, and so forth. You can run this task in two different conditions. In one condition, you just give people a single task and you tell them there's going to be a bunch of letters and all I want you to do is figure out whether there was a P involved or a white letter involved or not. In this case, a white letter was the task. Right? So if there's a white letter, afterwards tell me that there was a white letter. If there wasn't a white letter, tell me that there wasn't a white letter. You can also do this in a dual task situation where on top of the question about the white letter, you're also being asked whether there was an X amongst one of the letters. So in this case, if you had flashed all of these in quick succession, you saw the F, the L, the P as a white letter, so you'd say yes to that. O, X, O, J, X, and the X is the letter you were also supposed to look for, so that would be yes as well. What's interesting here is that you can play around with when the P shows up relative to when the X shows up. So you could do it maybe the very next letter, you could do a couple of letters in between, and you can actually play around with the length of that gap. What's interesting is that people are obviously, they're quite good at the single task, they can find the white letter very well, about 90% accuracy. But when you play around with the dual task and the time between the first task and the second task showing up, you see that if the X shows up right after the P, it's not so bad. People can detect it with about 75% accuracy. But if it shows up, say, 2 or 3 letters later, there's this massively reduced accuracy. And the reason for that is almost as if the attentional system is blinking because it's processing, hey, I just saw a white letter. Let me take note, pay attention, and note that I saw the white letter. While it's doing that, the attentional system is already occupied. And now if the X happens to show up in that time frame, you actually are very bad at detecting it. So you see there's this dip here, and that's called the attentional blink. Suggests that in some ways our attentional system engages in serial processing. It can only process one thing at a time. It's as if you've detected, hey, there's a white letter, the attentional system is occupied by that white letter, and now you're missing other things in the meanwhile. So that's the attentional blink. Now, a related phenomenon is called repetition blindness, where in some ways you have a similar type of task, but it doesn't involve letters, it involves these symbols. Imagine again that you sit behind a computer and you get a bunch of these symbols. This one first, then this one, then this one. Then you see an airplane, then some sort of anchor, and then an airplane again, and then another bunch of mumbo-jumbo symbols. After these things flash on the screen, you're then being asked to report any objects you saw. So the correct answer here would be an airplane, an anchor, and an airplane, and the correct answer here would be an airplane, an anchor, and a crocodile or an alligator. What's interesting is that if the time lag between the first airplane and the second airplane here is fairly short, then people will actually vehemently declare that they only saw one airplane and not a second airplane. And the thinking is that the attentional system for processing the first airplane is kind of keeping the whole concept of airplane busy, and because of that you actually fail to perceive the second airplane. Now you might think, well, it's because it looks visually exactly identical here, but you get the same effect even if you change the color of the airplane, the orientation of the airplane, if you see it from the back and from the front in the other case. It's because the attentional system has already sort of hijacked the processing of one airplane, and as a result you fail to see the other airplane. So that's 2 examples of failures of attention in time, because they suggest that the attentional system in a given time period can only process a certain capacity limit of information, and if it's already taken to process one thing, it will actually fail to process another thing. So that gives us some insights in how the attentional system works. We're going to talk about that more in the next video as well.